Good morning, children. So we'll start with the concept of couple today. All right. It is also called as the moment of couple. All right. Now, see, last time we have discussed the concept of moment of force. All right. Now, in moment of force, what we have learned is that here, uh, when you apply a force to, for example, take an example of door. All right. And when you apply a force at the handle, then the door will turn over there. All right. Now, in this case, there are we have to consider the effect of only one force over there. Here, we consider the effect of one force, the force which we apply at the handle. All right. But actually, if you see carefully, there are actually two forces are involved. Can anyone tell me that where is the second force over there? In an example of door, one force you apply at the handle. Is there any second force is there?
The second force is at the hinge.
Yes.
Yeah,
Second,
the second
yes.
force is at the hinge.
Yeah, second force is at the what? Hinges. All right. Because hinges are holding the door. In order to hold a door, you need a force. All right. So therefore, basically, in an example of door also, there are effect of two forces are there. One force you apply at the handle, and second is called as the force of reaction, which is produced at the hinges. All right. Now, but here, when we calculated the moment of force, have we considered the effect of both the forces, or we have considered the effect of only one force?
Only one force.
Only one force.
Only one force. And why we have done that? Why in moment of force, why we have considered the effect of only one force?
Because that's what the direction will be.
No, the reason behind is that here when you calculate the moment, at the hinges, what is the value of the moment at the hinges?
Zero.
Zero. Hannah, can you tell me that why at hinges the moment of force will be zero?
Zero.
Why it will
Sir,
be
your
zero?
voice is breaking.
Okay, just a minute. Okay, is my voice is clear now?
Yes, sir.
Okay, can you tell me that why at hinges the moment of force will be zero?
Sir,
Sir,
because
because
the
perpendicular
perpendicular
distance is
distance is zero at the
Yes.
hinges.
Yes, at the hinges, the perpendicular distance between the line of action and the axis will be equal to how much? Zero.
Zero.
Because at the axis only you are applying a force. All right. So the moment at the hinges will be zero. Therefore, when you calculating the moment of force, all right, then at that time the force over there is zero. All right. Now, but in some of the examples, all right, we have to consider the existence of two forces. Likewise, here you can see that you can see the turning the water tap over here, then tightening the cap of the ink bottle, turning a key in a lock, then sit quietly. What you're doing? Okay, all right. Now you can see that here. See the examples over here. Turning a water tap, then tightening a cap of the what? The blue ink, then turning a key in a lock or turning a stair wheel. In all examples here, you can see that we have to consider the effect of two forces. All right. You can see that one force is over here and second force is over here. Here also one force is here and second force is here. So here in this case, we have to consider the effect of how many forces?
Two forces.
Yes, here we have to consider the effect of two forces. Or in a simple way, if you take a water bottle, all right, when you have to open it, your both the hands goes like this. So here, you can see that there are two forces which are acting at two different points. They are equal and opposite, as well as they are in a what? Here they are parallel to each other. All right. So the effect of all these forces is called as the couple. All right. That's why when I write the word couple here, what I have written over there, the effect of two forces. Or if you take an example of steering wheel, then one hand goes like this and second hand goes like this. So there are two forces which are equal and opposite. So such an arrangement of the forces is going to form the couple. All right. So one more example they have given, the example of car range over here or simple range over here. You can see that when you use a car range, your one force goes like this and second force goes like this. Here also, here one force goes like this and one force is upward. So you can see that, see the arrangement of forces over here. Both the forces are equal in magnitude, they are oppositely directed, as well as they are parallel to each other, and here they are also acting at two different points. So such a arrangement of the forces is going to form the couple. Is everyone is clear with the idea of couple?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes, sir.
All
Your
right.
voice is breaking.
Yes,
Okay. Okay. Is everyone is clear with the idea of couple?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes.
Okay. Okay. Now,
Yes, sir.
so here, therefore I have written a definition over here. Two equal and opposite parallel forces not acting along the same line forms the couple. They are not acting along the same line means they are acting at two different points. Clear? All right. Now, let me tell you that here, if there is a moment of force or there is a what? A couple, both of them produces the turning effect. Or sometimes in a textbook, you will get confused that both of them are called as a torque. But then what is the difference between them couple and the moment of force? See, both of them have the same ability. Both of them will produce a turning effect. But what's the difference between them couple and the moment of force? The first difference is that here, in case of the moment of force, we have to consider the effect of only one force, and in couple, we have to consider the effect of how many forces?
Two
Two
forces.
force.
Two forces. In case of the couple, we have to consider the effect of two forces. Now, one other difference is that here, when you calculate the moment of force, all right, if you change the axis of rotation, see what I'm saying? In case of moment of force, if you change the axis of rotation, the value of the moment of force will change. But in case of moment of couple, even if you change the position of the axis of rotation, the value of the moment of couple will always remain the same. So moment of couple is independent of the axis of rotation. But the moment of force will depend upon the position of axis of rotation. Clear?
Sir, can you explain this again? Your voice is breaking.
Okay. Okay. 1 minute. Is my voice is clear now? Hello?
Yes, sir.
Yes, sir. Yes,
Okay.
sir.
Okay.
Yes, sir.
Okay. Now I was telling the difference between the moment of force and moment of couple. In moment of force, when you have to calculate the moment of force, you have to consider the existence of only one force. But in case of moment of couple, you have to consider the effect of two forces. Is everyone is clear with this?
Yes,
Yes,
sir.
sir.
Yes, sir.
Okay.
Sir.
Now, second difference between moment of force and moment of couple is that here the moment of force will depend upon the position of axis of rotation. But when you calculate the moment of couple, then it does not depend upon the axis of rotation. All right, you can take axis of rotation anywhere, but every time the moment of couple is going to comes out to be the what? Same. All right, so this is the main difference, but both of them have a same tendency to produce a turning effect. All right, so that's the difference you should remember between the couple and the moment of force. All right, so last time they are in an exam they have asked a definition of couple, and it's one of the examples. So you have to remember this definition, and you can remember what the one of the example. Clear?
Yes, sir.
Yes, sir.
Okay. Now, very important part. Now, here we have to write the formula for couple. All right, just like we have written the formula for moment of force, right now we are going to write the formula for or how to measure the couple. All right, now you can see that I have written one statement over here, and you have to remember this statement. In couple, we have to consider the effect of two forces. That's why here what I have written is that when you have to calculate the moment of couple, it is the sum of the moment of forces forming that couple. All right. How to calculate the couple? It is the sum of the moment of forces forming that couple. Now, what is the meaning of this statement? All right. Now we can see that is everyone is able to see the diagram over here? It is also in your textbook.
Yes, sir. Yes,
Okay.
Yes, sir.
Now everyone see over here. You can see that this is the line AB over there. You can consider the rod AB over here. All right. And at point B, we are applying the force in upward direction. This is the line of action. And at point A, this is the line of action. All right. So you can see that there are two forces which are equal and opposite, and they are parallel as well as they are acting at two different points. So I am saying that they are going to form the couple over here. Clear? Now I am going to calculate the value of couple over here. Let my point O is my pivot. Point O is my pivot, or I will say that it is my axis of rotation. All right. So remember that when you calculate the moment of force or moment of couple, the position of the axis of rotation is your reference. Just like on a number system, origin is your reference. Everything you measure with respect to origin. In case of moment of force or moment of couple, the position of pivot, just like in this case, the point O is your reference. All right. Now we are going to calculate the value of the moment of couple. Now, Siddharth, can you tell me that if point O is my pivot, how many moment of forces are acting over here?
Sir, 2.
Yeah. Now there are two moment of forces because O is my reference, is my axis. So you can see that first line, the moment of force F at the end A. So that moment will be equal to the what? We know formula for moment of force. It is the magnitude of the force into the perpendicular distance between line of action and the pivot. So therefore, here the first moment is F into OA. You can see that this is the moment arm over here. OA is the moment arm. So this is the first moment. Now that moment is anti-clockwise. How they have decided it is anti-clockwise? See the line of action. Where the force is going? It is going downward. When it is going downward, so this rod AB will start moving like this. This rod will start moving like this. That's why it is anti-clockwise. Clear? Now this is the second moment over here because this is my axis. So therefore, the moment of force F at the end B will be equal to F into OB. Now OB is the moment arm. Now again, this is going to be a what? Anti-clockwise. So you can see that if this force is upward, so this rod will start moving in like this. All right. So again, it is going to be a what? Anti-clockwise. All right. And if you remember the sign convention, what is the sign convention for clockwise and anti-clockwise movements? Prajot?
Sir, I don't remember.
Rick, can you tell me the
Clockwise
sign
is
convention?
negative.
Clockwise is
Clockwise
negative and anti-clockwise movement is positive. Now here both the moments are anti-clockwise. Both the moments are anti-clockwise. So I will take both of them as positive. So therefore, when I am going to calculate the moment of couple, how to calculate moment of couple? You can see that that is the moment of both the forces. So we have to consider both the moments over here. And as both of them are anti-clockwise, so what symbol is over here? Naman, which symbol is over here?
Addition plus.
Yes, addition. Addition. Why addition? Because both the moments are positive. Therefore, the total moment of couple is F into OA plus F into OB. Therefore, F will be common between these two. If I take F as a common, inside the bracket, you have OA plus OB. Clear?
Yes,
Yes,
sir.
sir.
Okay. Now, what is
Yes, sir.
OA plus OB? That OA plus OB is nothing but the what? AB. All right. So therefore, an AB, that distance AB is called as a small d. All right. So therefore, our moment of couple will become F into small d. Now this small d is called as the couple arm. That small AB is called as a what? Which arm is called as a couple
Couple arm.
arm.
Couple arm.
Okay. So therefore, your formula for moment of couple will become magnitude, either a force, any force, because both the forces are equal and opposite, into the perpendicular distance between what? Two forces. You can see the difference, the formula between moment of force and moment of couple. When you calculated the moment of force, it was the perpendicular distance between the axis of rotation and the line of action. But here, moment of couple, it is the product of two terms, magnitude of the force and the perpendicular distance between two parallel
The
forces.
two forces.
Yeah. So have you understood the difference between the moment of force and moment of couple?
Yes, sir.
Yes, sir.
Yes,
Sir.
sir.
Yes,
Okay.
sir.
So this is a very, because in the exam student get confused. All right. So when we come to the numeric,
again?
which one? This formula?
Yes, sir.
Okay. Now you can see that when you have to calculate the couple, I told you that you have to consider the effect of two forces. You have to consider the effect of two forces, because if you remember these examples here, everywhere, just like this, tapping the water tap. All right. Here, you can see that is the effect of two forces is there. Yes. Is the effect of two forces there? You can see that.
Yes, sir.
Here is a one
Yes,
force,
sir.
a second
Yes, sir.
force, one force, second force. But in moment of force, you have to consider the effect of only one force. All right. Because the second force is always comes out, the second moment is always comes out to be zero over there in case of moment of force. All right. But here, in case of moment of couple, there is the effect of what? Both the forces. It's like a steering wheel. All right. One force is like this, second force is like this. Car range, one force is like this, second force is like this. So therefore, in moment of couple, there is the effect of two forces. All right. So therefore, how to calculate moment of couple then? What statement is over here? It is a sum of the moment of forces forming that couple. The couple is always formed by two moments. All right. So therefore, if O is my pivot, then this, what is going to be my first moment? So moment of force, first one is going to be F into the moment couple, that moment arm, that is OA. Okay, this is my first moment here. Now what is my second moment? This F into OB is my second moment. Now, and we say that along with the magnitude, you have to consider their direction also, because they are, it is a vector quantity. All right. And I told you that how come they are going to, both of them are going to be anti-clockwise. How to decide they are clockwise or anti-clockwise? See the direction of line of action. You can see that if this is my fixed point and this line of action is downward, if I apply a force downward, then this this force is coming in a what? Downward direction. So this rod is going to rotate like this. So if the rod is going to rotate like this, it is going to be a what? Anti-clockwise. Same thing, second moment. Here, this force is upward. If there is a rod, and if I apply the force upward, then the rod is going to move like this. So again, it is going to be a what? Anti-clockwise. So that's why when I'm going to form the total moment of couple, then between, this is my first moment F into OA, this is my second moment F into OB, and here I have taken a plus sign. Suppose one of the moment is clockwise, then there will be a what? Negative sign will come over here. Clear? So the plus or minus sign depends upon whether the moments are clockwise or anti-clockwise. Now in this case, both of them are anti-clockwise. So therefore, we have taken the sum sign over here. And F into OA plus OB is comes out to be a what? AB. And therefore, AB is called as a small d. And then moment of couple, the formula is either the force into the perpendicular distance between the two parallel forces. Clear, children?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Okay. Now my question is to Prajot. Can you tell me the unit of
Yes.
this moment of couple then?
Newton meter.
Newton meter. Again, it is going to be a Newton meter, just like a moment of force. You can see that it is a force into distance. So for force, it is Newton. For distance, it is meter.
Meter.
Okay. So both the moment of force and moment of couple have the same unit. Both of them have the same effect of turning. But have you remember the difference between them? In moment of force, you have to consider the distance between line of action and the axis. But in moment of couple, you have to consider the distance between the two parallel forces. Clear?
Yes, sir.
Okay.
Yes,
Here,
sir.
okay, that's good. Now, here, this is the concept of the moment of couple and the moment of force. You should know the clear-cut meaning of this moment of force and moment of couple. Or in numericals, you will get the exact idea what is the difference between them. All right. Now we'll just switch to our next point, and that is a very, very important point: the concept of equilibrium of bodies. All right. Now, can anyone tell me that what is the meaning of the word equilibrium from the physics point of view?
Equal and opposite forces.
No, that is different. Now, everyone, please pay attention here.
Equal and cancelling forces.
Yes, you can say that. All right. The word, simplest meaning of the word equilibrium from the physics point of view is that the body will be in the stable state. The body will be in the relaxed position. The body will be in the rest position, or the body will be in the uniform motion. All right. So all of these words will give you what? The one meaning, that is called as the equilibrium. Clear? All right.
Yes, sir.
So
Yes, sir.
whenever I say that the body is in equilibrium, the first meaning that comes in your head is that the body is in a stable state. The body is in a relaxed state. Clear? Now, what is this concept? Equilibrium of
Yes.
bodies. All right. Last time we have learned that if any body is free to move, or if any body is pivoted, and if you apply a single force, what I said, if you apply a single force, then the body will perform either a linear motion or body will perform the rotational motion.
Rotational.
Clear? Now, in this case, when only single force is acting on the body, then in that case, we can say the body will be unstable. All right. Just like here, I have taken this body and I am applying this force on this pen so that it is moving upward. So I will say that this pen is not in equilibrium. All right, because I am applying a single force, so therefore this pen is unstable. All right. Now, or here, when you accelerating your vehicle, then in that case, that body is having the acceleration, which means that you are applying a force on that, and that body will not be in a equilibrium. All right. Now, but in some situation, what happens is that number of forces, there can be a 2, there can be a 3, there can be a 4. There are several forces. When those several forces acting on that body, and under the action of those several forces, under the action of that several forces, the body will either be in a state of rest or the body will be in a uniform motion. What I said, under the action of that several forces, either the body will be in the state of rest or the body will be in the state of uniform motion.
State of motion.
Now, can anyone tell me that what is the meaning of the word uniform motion?
Constant motion.
Sir,
What is-
moving with a constant speed.
Yes,
Yes,
exactly.
sir.
The body is moving with a what? Constant speed. That is the meaning of the word uniform motion. All right. In ninth grade, we have learned this. What is the graph or the graph of meaning of uniform motion? All right. So therefore, when number of forces are acting on the body, and if you find that the body is in a state of rest or the body is in a uniform motion, now there can be two types of motion. There can be a linear motion or there can be a what? Rotational motion. All right. So if the body is in a state of rest or if the body is in linear motion or if the body is in a uniform rotational motion, in that case you say that the body is in a equilibrium. Clear? Have you understood the meaning of this statement? When number of forces
Yes, sir.
acting on a,
Sir,
acting
can you repeat?
yeah, when number of forces acting on the body produce no change in the state of rest or linear motion or rotational motion, the body is said to be in a what? Equilibrium. When number of forces are acting on the body, all right, but under the action of those number of forces, you will find that the body will be in the state of rest or the body is moving with a uniform motion or the body is performing the uniform rotational motion. In that case, we say that the body is in equilibrium. Let me give an example to you so you will understood the meaning of that statement. If I take an example of the fan, is your fan is, when you switch on the fan, is the fan start moving with a uniform speed? Is a
No.
fan
No,
is,
sir.
No.
how come?
So you said now, like when it start,
No.
it start from slow and then it go fast.
Yeah, it's okay. Now, but in that case, here, once it starts motion, after some time, what will happen over there?
Sir, it will show
It will be uniform. It will be
Yeah,
uniform.
it will be in the what? Uniform
Uniform.
motion. All right. So therefore, that is the example of the what? The equilibrium position, because it is moving with a what? Uniform rotational motion. All right. Now, here, so we say that either the body will be in the what? The state of rest or the body will be in the uniform motion. So depending upon that, here we have two types of equilibrium. Either the body will be in the state of rest or the body will be in the what? State of uniform motion. So you can see that the kinds of equilibrium over there. The first one is a static equilibrium. The word static means stationary. The word static means stationary.
Stationary.
All right. So what will happen in static equilibrium? There will be a number of forces are acting on the body. There will be a number of forces acting on the body, but under the action of those number of forces, the body will be always in the state of rest. What are the examples? You can see that there is a one object which is placed on a table. Are you able to see this object over here?
Yes, sir.
Yes, sir.
All right.
Yes, sir.
You can see that one force is acting like this and second force is acting like this. So how many forces are acting over there? Two forces, and both the forces are equal and opposite, and both the
Opposite.
forces are acting on the same body. Both the forces are acting on the same body.
Same body.
So the net effect of the force will be how much?
0.
Zero. Net
Zero.
effect will be how much?
0.
Zero. All right. So
0.
when resultant or the net force is acting on the body is zero, the body will be in the what? Rest position. The body will be in the rest position. So
Rest
this is an example of what? The static equilibrium. There are two forces are acting on the body and the body is in a state of rest. Clear? Now,
Yes.
Yes, sir.
second example given in the textbook is what? Book lying on a table. Again, so when you place a book on a table, there are two forces are acting on that book here. One force is exerted by the book on a table, that is action. At the same time, the table also exerts a force on the book, that is force of reaction.
Reaction.
And you can see that both the forces are equal and opposite.
Opposite.
So therefore the book is in a what? Rest position. The book is in a what? Rest position.
Respiration.
Clear, children?
Yes, sir.
Okay.
Yes, sir.
Yes, sir.
Yeah. So that is the example of static equilibrium. All right. Still the number of forces are acting on bodies, but the body is in a what? State of rest. Now, second example, the beam balance. Everyone is familiar with the what? Beam balance. You can see the pointer at the center over here, and there are left pan and the what? Right pan. So in this case, the body, can I say that the body is pivoted at one point? The body is pivoted at this point. Students?
Yes, sir.
Okay. Now, the body is pivoted over here. Now, in this case, suppose in the right pan, I am going to put the weights, and in the left pan, for example, I am putting vegetables. All right. Now, what will happen? With my hand, I am holding it over here. So this is my pivot. This is my pivot. So in this case, if the weight in the pan is, this is right pan is more. So in this case, this I will say that the clockwise movement will be more. Is it? If the
Yes,
weight
sir.
in the right pan, because that is going to move it what? Like this. So
Yes,
in that case,
downwards.
the clockwise movement is more. All right. So the point is the position will be at the center or the pointer will shift to the right. If the weight in the right pan is more, so what is the position of this
Shift to the
pointer?
right.
It will shift to the what?
To
Right.
the right. To
So
the right.
in this case, I will say that clockwise moment is more than the anti-clockwise moment. Is it?
Yes.
Here will be
Yes.
the
Yes.
clockwise moment,
Yes,
and here
sir.
will be the what? Anti-clockwise moment. Kaushiki, are you able to understand this?
Yes, sir. Yes.
Okay, because I'm saying the weight in the right pan is more. When clockwise moment is more than anti-clockwise moment, are the two moments are cancelling each other? Are the two
Can
moments
you
are,
repeat the question?
yeah, If I'm saying clockwise movements is more than the anti-clockwise movement, are both the moments are cancelling each other?
No, sir.
No,
No.
sir.
That's
No,
why the
sir.
pointer is not at the center. Suppose if the vegetables in the left pan is more, all right, vegetables in the left pan is more, then I will say anti-clockwise movement is more. Again, the pointer will shift to the left.
Yes.
But at one point, what will happen when weight in the pan and the weight of the vegetables in the left pan is equal? In that case, you will find that the pointer will be at the center. The pointer will be at the center. So in this case, we'll say,
Center.
yeah, pointer is at the center, which means that both the clockwise movement and anti-clockwise movements are equal and opposite, and
Opposite.
we'll say that that beam balance is in a static equilibrium.
Static equilibrium. Yeah.
Yes, under the action, here we'll say that under the action of number of forces, the body is in a static equilibrium, and here in beam balance, I will say under the action of number of moment of forces, because here the body is pivoted. All right, here the body is not pivoted. So that's why I will say that in this case, under the action of number of forces, here I will say under the action of several or number of moment of forces, the body is in a static equilibrium. Clear?
Yes, sir.
Yes, sir.
Okay, good. So this is the concept of the static equilibrium. All right. Now second equilibrium, you can see that here is called as the dynamic equilibrium. Now I told you that we have two states over here. State of rest. For that you have static equilibrium. Now if the body is in a uniform motion, that can be either a uniform linear motion or that can be a uniform rotational motion. Now in both the cases, we will say that here under the action of number of forces, the body is in a state of uniform linear motion or state of uniform rotational motion. In that case, the body is in a dynamic equilibrium. Clear?
Yes, sir.
Okay, you can see the statement over there. Statement is very important. When a body remains in the state of motion, it can be a state of uniform linear motion or state of rotational motion. Under the influence of several forces, the body is in a dynamic equilibrium. Clear? Now we'll try to understand the meaning of this statement with the help of this example. Here, first example, the motion of the raindrop from cloud to the earth surface. Now, whenever there is a raining, all right, when the raindrops are coming in a downward direction, they actually moves with a constant velocity, and it is going to be a constant linear velocity. Why this happens? You can see that this is a raindrop. So this is the direction of motion of a raindrop. This arrow indicates it is coming downward. Now, can you tell me that how many forces are acting over there on a raindrop when it is coming downward? You can see that one
The
force,
two,
there will be a three forces are acting over there.
So there will be two, right?
Yeah, there will be a three forces. Why three forces? Everyone pay attention over here. First, that raindrop have some weight. So under the action of the gravity, the weight of the raindrop is acting downward, vertically downward. Now, second thing is that here, when the raindrop is coming downward, that raindrop is exerting a force on the air. So which means that air will also exert a force on the raindrop. That is called as the upthrust. Everyone knows the meaning of the word upthrust. It is also called as a which force?
Buoyant force.
Yes, it is also called as the buoyant force. All right. Now, second upward force is that viscous force. We know that air resistance, concept of air resistance. All right. When any body is moving through the viscous medium, just like the air, all right. So in that case, under the action of the motion of this raindrop, the viscous force will always act opposite to the what? Direction of motion. What I'm saying, as the raindrop is coming downward, so direction of viscous force will be always opposite to the direction of motion. If the raindrop is downward, the viscous force will be upward. Clear? All right. So therefore, you can see that
Sir, can you
the
repeat that?
yeah, I'll repeat that. Now, one force is acting vertically downward. That is the effect of gravity. Everyone knows that. Second force is the upthrust, because raindrop is exerting a force on the air. So air will also exert a force on the drop. That will be upthrust. So this is upthrust will be upward. This is the force of reaction. Now, what is a viscous force? See, the air medium is a viscous force. It also has a friction. Everyone knows the meaning of the word friction. All right. Just like in solids have a friction, just like in a fluids, just like air, it also has a force of friction. And everyone knows that what is the direction of the force of friction? The force of friction will be always opposite to the direction of motion. In the ninth grade exam, you have this question, annual exam. What is the direction of force of friction? It is always opposite to the direction of motion.
Motion.
Clear? Yeah. So therefore, we say that these three forces are acting on the raindrop. Now, how they are going to balance each other? When the drop is coming downward, so initially the weight of the raindrop is more, and slowly, the value of these two forces will goes on increasing. And at one point, see what I'm saying? At one point, the weight of the raindrop is equal and opposite to the upthrust and the viscous force. So will be equal to the weight will be equal to the upthrust plus the viscous force. And which means that if I'm saying weight and these forces are equal and opposite, what is the net force acting on this raindrop?
Zero.
Zero. And when you know that Newton's first law, when no force is acting on the body, either the body is in a state of rest or the body is moving with a what? Uniform motion.
Motion.
So in this case, net force acting on the body is zero and the body will be in the what? Uniform motion. Another example, the best example is skydiving. All right. So in a skydiving, what happens when that person is going to jump from a plane? So initially, what happens? That person come in a downward direction with a large acceleration, because initially the weight of that person is what? More compared to the upthrust and the viscous force. But slowly, what happens? At one point, that person come in a stationary position, or that person moves with a what? Uniform speed. The reason behind that, weight of that person is actually balanced by the what? The upward upthrust and the what? Viscous force. So therefore, the net force acting
Sir,
on, yeah.
sir, if the body and the upthrust and viscous force equalize each other, doesn't the
Yeah.
raindrop stop
No,
midair?
not necessary. It has the inertia of motion. The raindrop has the inertia of motion. How come? So net force is zero, which does not mean that every time it has to come in a rest. Newton's first law, either will be in the state of rest or state of uniform motion. So initially the raindrop has the inertia of motion.
Okay.
All right. So even if a net force is zero, then it is coming with a what? Uniform motion. All right. So have you understood that example?
Sir.
Okay. Now second
Yes, sir.
example of aeroplane. Now when the aeroplane is taking off, in that case, what happens is that the whole weight of the aeroplane should be balanced by the what? The uplift. Clear? So until and unless this gravity, that is the weight of the force, and this lift are equal and opposite, all right, then and then only, if these two forces are equal and opposite, then and then only here the aeroplane will start moving with the what? Uniform motion. All right. So therefore, this is a second example, the lift of an aeroplane. Is everyone is clear with these two examples?
Yes, sir.
Sir.
All right.
Yes, sir.
Now remember that
Yes,
in
sir.
Yes, sir.
yeah, yeah. Remember that in an exam, they will always ask a question. They will ask a question. Explain the concept of dynamic equilibrium with the example of raindrop. So, is
Sir, even I can't.
yes, okay. My question is to Avanti. Avanti, are you there?
Yes, sir.
Okay. So my question is that can you explain me the dynamic equilibrium with the example of this raindrop?
I can't hear you.
Okay, I'll just repeat that. Can you uh, can you explain me the concept of this dynamic equilibrium
Yes,
with the help of this raindrop?
The raindrop is in dynamic equilibrium because the weight of the raindrop is
Yes,
the raindrop is under gravitational force because of
yes,
its weight,
yeah.
and since it's moving through air, the air is
Hmm.
the raindrop is doing a force on the air, so the air is
Yes,
also
exerting a force on the raindrop.
yes, sir,
Yeah.
which is the upthrust, and
Yes,
then these forces are equal and opposite,
yes,
along with the force of friction, which is
yes,
moving in the opposite direction of the motion of the raindrop.
yes.
So
Excellent.
the net force is at zero, which
Yes.
is why the body is in state of
Const.
uniform motion.
Yes,
Hence, it's in
exactly.
dynamic equilibrium.
Yes, very good, excellent. And same thing happens in case of aeroplane. The weight of the aeroplane is balanced by the lift. All right. So therefore, these two forces are equal and opposite, or you can also say the thrust and the what drag. So they are equal and opposite. So therefore, the plane is in a what uniform motion. Clear? Now, the another very important example, that is the motion of the planet around the sun. Everyone pay attention over here. Now, my question is why planets are able to revolve in a circular orbit around the sun?
Sir, because the gravitational force is acting on
Yes,
them
yes,
of the
yes,
sun.
yes. Very important. This thing. Here we know that
But
there
it's
is a
but it's like the pivoted motion type,
what is
the
pivoted
rotational one.
motion.
Sir, sorry, sir. The means it the sun is pivoted and the earth is rotating.
Okay, I'll just yeah, I'll just explain this. So this is the planet over here, and here is the sun. All right. You every time you can see that because of the gravity of the sun, the planet is every time it is pulled inside. All right. And because of this gravitational force, the planets are able to revolve in a circular orbit. All right. So without without this gravitational force, no planet will able to move in a what circular orbit. Just imagine that the sun is not going to exert a gravitational force. Just imagine that this force is disappear. So how much is the net force acting on the planet then? What is the net force acting on the planet then if there is no gravitational force?
Sir, zero maybe?
Zero. Yeah, it is zero. And Newton's first law says that if no force is acting on the planet, then if no force is acting on the planet, then the planet will start moving in a what? Straight line. The planet will start moving in a what? Straight line. That is along this red line. All right. But because of this force, the planet is not going like this. It is moving along the what? This track. It is moving along this track. Clear? All right. So therefore, we say that this is the direction of motion of planet. This is the planet's velocities along this direction. But this straight line path becomes a circular because of this gravitational force. Clear? All right. Now,
Yes, sir.
in this case, I will say that the planet is in a dynamic equilibrium. Now, can you tell me what is the time period of the Earth around the Sun? Everyone knows the meaning of the word time period.
65 days.
It is 365 days.
365 days.
Is the time period of the Earth? If I say that the time period of the Earth is same, I think it is. There are 2 minutes, so in a 1 minute I will finish this topic. Okay. Uh, in a when the if a time period is same, can I say the planet is moving with a uniform speed?
Yes, sir.
Okay, so
Or the speed of Earth changes, right? It's
no,
not
no,
constant.
no. If the orbit is elliptical, in that case it happens. But the orbit of Earth is almost circular. So everywhere the speed of the Earth is going to remain the same. Clear, Siddharth? If the orbit is circular, if the orbit of the planet is circular, then in that case it is uniform speed. But here, if the orbit is elliptical, in that case the speed changes. But the orbit of Earth is circular.
Sir,
Clear?
I always thought that the orbit of Earth is also elliptical.
No, no, no. It is slightly elliptical, but approximately we take it as circular only.
Okay, sir.
Okay. So therefore, here, so everywhere the Earth is almost at the same distance from the Sun. So now, what I've written over here, the formula for the work done. What is the formula for work done? F force into displacement into cos theta, where theta is the angle between the force and displacement. Now in this case, this is the direction of force and this is the direction of planet velocity. What is the angle between them? This is the displacement of the planet, red line, and the blue line is for the force. What is the angle in between them?
90 degrees.
90. 90. And what is the value of cos 90?
0.
0.
0.
So therefore, in this case, the work done by the gravitational force is how much? The work done by a gravitational force is how much? 0. 0.
0.
The work done by
Zero.
the work done by gravitational force is 0. And whenever there is no work done means what? The body, there is no change in its speed. Whenever there is a work done, then and only the speed changes. But if there is no work done, so speed will remain constant. Clear?
Yes, sir.
Okay.
Yes, sir.
When there is no
Yes,
work done,
sir.
yeah. So therefore, the motion of the planet around the sun is an example of what? The dynamic equilibrium.